Hi Year 9. Today we're going to talk about mutually exclusive and independent events. So mutually exclusive are if two events cannot occur at the same time. So they're two things that can't happen at the same time. So we've got a little example here of two events. If A's prime numbers and B's even numbers, then A and B are mutually exclusive. So you can see here, if we're looking at things on a Venn diagram, they are mutually exclusive. Okay, there's no crossover, there's no intersection. Our intersection is null. Now please note that I've said there null, that there's nothing in that set. Okay, there's nothing in the set of intersection of A and B. It does not mean zero. Okay, it does not mean zero, it means null. Okay, another way to think about it is that the probability of A or B, which is the probability of union AB, probability A union with B, is probability A plus probability of B. Okay, let's do an example. I've grabbed this from the book. A card is drawn from a pack of 52. What is the probability? The probability that the card is a king or an ace. Or there's an important word. So in other words, we're looking for the probability of a king or an ace. Now these are mutually exclusive events, aren't they? They can't occur at the same time. So what's the probability of a king? There's 4 out of 52. Or getting a ace, there's 4 out of 52. So you can simplify those fractions first and then add them up, or add them up then simplify. Usually we simplify the fractions first, so that's 1 out of 13, 1 out of 13. So that means the probability of king union with ace is equal to 2 over 13. That's the probability of king or ace, or in other words, probability of king union ace. Now this is for a mutually exclusive event. Remember that this is a mutually exclusive event because they can't occur at the same time. So let's think about independent events. Independent events are when two events, if the outcome of one event is not dependent on the other outcome. So think about, the probability of tossing a head is not influenced by what you've tossed previously. If you've tossed 50 heads previously, it still doesn't affect the probability of tossing a head the next time. So let's do this example. A circular spinner is divided into 2 equal halves, coloured red and blue, and is spun 3 times. So you can imagine the spinner like so. Imagine a circle and they're even. We've got red and we've got blue. Okay. So that probability of spinning either of them is 1/2. So let's draw our tree diagram for this experiment. So move this down a bit. So this is for spin 1. We can have red or blue. It's probability of 1/2 either way. Spin 2. You can have red or blue, red or blue. And again, that probability doesn't change. So spin 3, red, blue, red, blue, red, blue, red, blue. Okay. Again, the probability of all of these remains 1/2. Okay. So I'll write out our sample space just so you can visualize it a little bit. We've got red, 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 blue, red, blue, red, red, blue, blue. Okay, then blue, red, red, blue, red, blue, 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 red, and blue, blue, blue. Okay, that's our sample space. They're all the potential outcomes. So our probability of 3 red sectors, let's do a few of these, 3 red sectors. Now, remembering, these are independent events. They're not influenced by what you've done previously. Okay, so that probability hasn't changed. So that probability of 3 reds is 1/2 times by 1/2 times by 1/2. Okay, so that's 1/6. Okay. Now, when you start to consider these ones like 2 red sectors, you've got to take into consideration all the ones that have 2 reds on them. Okay. And then, so probability of 2 red. So we've got that one, which will be a 6th. Plus probability of that one, which will be 1/6, plus probability of that one, which will be 1/6. So we've got 3/6, which gives us 1/2. Okay. The other one I want to just point to is probability of at least 1 red sector of at least 1 red. That means at least means we can have 1 or more. Okay, 1 or more red. The other way I can think about that is it's 1 minus the probability of 3 blue, because that's the only one that doesn't have at least 1 red. All the rest of them have at least 1 red. So that's a slightly easier way of thinking about it. So that's 1 minus 1/6. So that's 5/6. Probability at least 1 red. Okay. Now, as independent events were events where the outcome of one is not determined by or not influenced by what you've done previously. Dependent events are where the probability of an event occurring is influenced by what's happened previously. So the other day when we were drawing marbles from a bag, then drawing another one without replacement. Okay, so there are 2 yellow tickets, 3 green tickets, and 4 black tickets in a jar. Choose one ticket, replace it, then choose another ticket. Find the probability that a yellow ticket is drawn first, then a black ticket. Okay, so we've got yellow, green, and black. So yellow, green, black. There are 2, 5, 9 tickets in total, 2 of which are yellow, 3 are green, so that's 1/3, and 4 are black. 4 on black. Okay. Choose one ticket, replace it, then choose another. So here, I'll redraw that a little bit. So with that one, we are replacing it. So our probabilities remain the same because we still will have 9 tickets in the bag to choose from. Green, blue, 2 on 9, 1/3, 4 on 9. Yellow, green, blue, or black I should say, 2 on 9, 1/3, 4 on 9. Find the probability that a yellow ticket is drawn first, then a black. So looking here, it's yellow, then black. So that probability of yellow, then black is equal to 2 over 9 times by 4 over 9. So probability yellow then black. So 8 over 81, and don't think that simplifies down anymore. But now look at the difference, what happens now that we're not going to replace it. Okay, so let's draw up our tree diagram again. I like a tree diagram, but I always seem to draw them too small. Okay, so yellow, green, black. Now, that first draw is still unaffected by by the change of the without replacement. Okay, but what is changed is the second draw. Okay, so now there's only 8 tickets to choose from. So there's 8 tickets to choose from, one of which now will be yellow. There's still 3 green, and there's still 4 black. So yellow, green, black. There's still 2 that are yellow. Now there's only 2 that are green. And there's 4 that are black. Okay. And with this one, all right, there's Still 2 that are yellow. There are 3 that are green. Now there's only 3 that are black. So now we're looking for the probability of yellow then black. So that is 29 times by, well, 1/2 yellow and black. So that's 2 over 18. Probability yellow, black. Simplify that because that is 1 over 9. Okay, so look through the worked examples and go through the work. I'll speak to you later.